Hi everybody, we're going to take a look at a typical control relay. The relay is used in our class, but anyone interested in how a control relay works in general, I'm hoping this video will be able to help you too. So let's get started. Parts of a relay consist of a coil, which is an electromagnet. If you run a little current through a coil of wire, it'll create a magnet, and you can use it to actuate a mechanical lever or a number of things to either connect a circuit or do a number of things. We use a relay so that a small amount of power can be used to control something that controls a lot of power. So for example, the little tiny bit of power that it takes to energize that coil, you can use to close a contact in a relay. In the little relays we use, the contacts are capable of handling 10 amps. That's quite a bit of power. And so you would need a much larger switch to switch that 10 amps than you need to turn on the coil of the relay. If you have several contact configurations, you can, like multi-pole relays, you can switch different voltages to different devices and do some somewhat complicated control with it. So let's take a look at the different types of relay contacts. We have a single pole, single throw. It's just a switch. That's all it is. A single pole double throw can switch between two different destinations or two different outputs. You can increase the number of poles and get more and more complicated with a double pole single throw and a double pole double throw. So looking at all these, what kind of relay are we using in class? Out of these different relay contact configurations, which one are we using in class? It's like this. This is a very common relay. It's a double pole, double throw. Looking at this relay, can you identify the poles? Can you identify the normally closed contacts? The normally open contacts? And the terminals for the common? Notice the coil down at the bottom. The relay we use in class is at 24 volts DC. The positive terminal is 8. The negative common is 7. So out of this types of relay configurations, contact configurations, which one is it? The double pole double throw, also known as the DPDT and the 2PDT. You might see it written any one of those ways. So let's say we're going to use the left pole. How would we connect two lights where one light would be on when the relay is de-energized and a different light would be on when the relay is energized? We're using the left pole. Where would we put those lights? We put those lights at terminals 1 and 3. Why didn't we put one of those lights on terminal 5? We're going to find out in a minute. So we put a yellow light on terminal 1, and we want it to be on whenever the relay is disengaged, and we have a green light. We're going to put it on terminal 3. We want it to be on whenever the relay is energized. So in order to accomplish that, where would we put the power? Seems kind of obvious now looking at it like that. We would put the power on terminal 5. So 5 is connected to 1 whenever the relay is de-energized. When we energize the coil, now 5 is connected to 3. So let's watch this relay operate a couple of times. It's off, yellow light is on. It's on, the green light is on. Yellow light, green light. Yellow light, green light. So looking at the left pole, We see how the normally closed and normally open contacts work, but which one of the terminals must have power on it all the time in order for this to operate? It's got to be terminal 5. We're going to put our voltage on terminal 5 all the time. That means terminal 5 is the common. This is an important term to remember when you're dealing with relays. 5 is the common. Looking at the right pole, what would be the common over there? It would be 6, wouldn't it? So now that we've accomplished all that, let's look at this relay. This is a single pole, double throw relay. We're energizing the coil, and we see how the contacts work. Could you identify the coil contacts, the normally closed contact, the normally open contact, and really, most importantly, the common? Of course, these are the coil contacts. This is our normally closed, our normally open, and this one right in the middle is our common. This is the one that would be hot all the time in order to make that work like the one we just saw. So, could you draw a ladder diagram that shows how the left pole of this relay would operate if we energize the coil with a push button? Nothing fancy, we're just going to press a push button, it's going to energize the coil, and it's going to work like it did before. When the relay is off, the yellow light is on. When the relay is on, the green light is on. And we'll energize the coil by pressing the button. What would our ladder diagram look like? There's our ladder diagram. We have 2 power rails. The 24 volts is supplied on the left rail. The negative common is on the right. And then we show how the push button takes that 24 volts. It goes to terminal 8 of the coil. 24 volts is also connected to the common of the left pole, which is terminal number 5. The normally closed contact will go to the yellow light out of terminal 1, and the normally open contact out of terminal 3 will go to the green light. I hope this takes some of the mystery out of control relays. They all work pretty much the same way. They're not all the same, but there's a lot about them that are similar. And I hope this helps you a little bit, and thank you for watching.